Okay, thank you. I'm sorry for late. I was kicked out from my audience and I transferred to the other audience. Okay, let's wait for your colleagues. Okay, do you know your colleagues are going to join us or not?
It's our sixth lesson for today, so I don't think that it's a good idea to wait longer.
Okay, okay. I think that there will be two groups, so about 60 students. Okay, let's start. And my name is Sava Konstantinovich Tomsky. You can call me Sava for short. I will conduct you seminars for public economics. I know that today you had the lecture, and today we will solve problems for the topics of introduction, and we will solve problems for computing the competitive equilibrium for public goods as a private good and as a public. Our seminars will be held only online. You know that the second module in the HEC will be held only online. So I hope that you will participate in our seminars. The seminars problem sets you can find in the LMS, and the problem set number 1 and number 2 were posted already, and you can download it. So do you have the problem set, or I need to?
Are they put in a seminars folder? Where?
Yes, in LMS. Files, seminars, and seminar 1, seminar 2 files. Okay, I can drop the seminar files here in the Microsoft Teams. Today we have joint seminars for both groups, but we'll have 2 classes for 2 groups starting next week. Today we have only 1 lesson for everyone because you have the 6th class for today. And I think that no one going to join us, so let's start. And I need to remind prerequisites of the course. Course is math intensive, so you need to know how to find the Lagrangian derivatives, integral calculus, and so on. So please repeat and refresh your skills if you forgot something. Okay, and I recommend you to check the technical capabilities of your camera and microphone, because midterm and exam will be held online, and maybe they will be proctored. So you need the video and audio files in appropriate quality. Okay, let's start the seminar, and let's start with the first problem. We can consider an economy consisting of 2 identical consumers whose utility functions 2 ln xi plus ln g, where xi is the consumption of private good and g is the consumption of public good. Income of each consumer is 100. The prices of ice cream and firework are identical and equal to 1. Determine the amount of public good provided in competitive equilibrium. Who knows how to solve the problem? Maybe some ideas. Yes.
Maybe they will split their budget in proportion 2 to 1, meaning that each will spend $66 on ice cream, and what is left they will spend on fireworks. Maybe that way.
Okay. What do we need to do?
Well, it's like a Cobb-Douglas function, and
yes,
we know how to deal with those, and since the prices are equal to 1, it is clear that they will spend. They want to spend 2/3 of their budget on
okay.
ice cream and 1/3 on fireworks.
Okay, I understand your idea. Yes. Obviously, it's the Cobb-Douglas function, but generally, what kind of problems we should solve here? We need to maximize utility. Yes, generally. Generally, we need to maximize the utility with the budget constraint. Utility of the each consumers 2 ln xi plus ln g, And the budget, what will be the budget constraint here for each consumer?
XY plus GY is equal to 100.
Yes, yes. For the first point, we need determine the amount of public good provided in competitive equilibrium. So each consumer will consume GI, and if the consumer not identical, GI may be different for each consumer here. But here the consumers.
You know that we can't see if you write anything on your board. Do you write something?
No, not yet. Not
Okay.
now. I write. Так. Can you see the writing
Yes.
in Blackboard? Okay, fine. We can solve problems in the Blackboard here. So if someone have capabilities to write in the Blackboard, you are welcome. Okay, who wants to solve the problem? The idea is discussed, and now we just need technically provided the idea. You can use the Blackboard, or you can verbally say me, oh, good. Who is this?
It's me, Fedor.
Okay, thank you, Fedor. What do you write here? Please make some comments.
Yeah, as we know, the proportion of marginal utility to the price of each product in optimal solution should be equal. So
okay,
we can write this.
Okay. We know this from the standard microeconomics course.
Yeah, and well, if we then substitute everything, we will see that the budget. I mean, we deal with Cobb Douglas all the time, and by now we know that we should just add up the multiplier before the logarithm or the power, and it will be it will mean how much we should spend on that good. So
Okay, budget constraint, maybe we need, yes. Yes, the budget constraint is that the total amount of money we need to for private good and for public good. Yes, and we get that px and pg are equal to 1, so we can write that xi plus gi is equal to 100. a small comment for everyone. You can move the blackboard to see the part of the blackboard. Okay.
Okay, I don't know what else to write.
Is it consumption of public good? 33.3. Okay, maybe someone else has comments on it.
Well, there is a question whether they consume the same public good. So maybe it's not separated, and they both watch public fireworks. In that case, probably the solution might be different.
Yes, yes. Does everyone think that this is right solution?
Well,
we didn't use that G is public good, so maybe we need other solutions.
Can you repeat, please?
We didn't use that G is public good, so it's a solution for both private goods.
Yes, for the first point, we need to determine the amount of public good as a private good, because public good provided in competitive equilibrium. But I think that there is some mistake. Так. What mistake here? Fyodor, we need to use information that G is public good. So if someone consumes GI privately, utility will be conducted by G as a public good. So so our problem generally looks like UI is equal to 2 ln xi plus ln logarithm of G, and G is the sum of Gi and G minus I. G minus I is a public good provided to the second, to the other consumer. So each consumer will consume G fully.
Yeah, that's what I've been asking. In that case, it's like an oligopoly situation. when much depends on the order of terms.
Yes. It looks like some Cournot model or Bertrand model. Okay, generally we need to maximize this utility by xi and gi, but we have
Excuse me.
budget constraint. Yes.
What is the index of the second G?
Yes,
Brackets.
G is the sum of public good provided by the two consumers. G is G1 plus G2. So
Okay.
So Gi for I is equal to 1 is just G1, and G minus U minus I is just G2. For I is equal to 2, Gi is equal to G2, and G minus I is equal to G1. Got it?
Well, G is equal to the sum of two G's. That works for me. Let's say so.
Okay. I think that my audio has bad quality. Okay. The budget constraint as said further is equal to px to xi plus pg to gi, and it's equal to 100.
Excuse me, I have a question. So everything that is before the function you just wrote, with the max, so this is like wrong? This is a wrong answer, or this?
Yes, this is wrong because
Okay.
we here don't we think that G consumes only privately, but the real situation is that G is paid privately by each consumer fully. Can you understand it?
Yeah. Okay, thanks. So
yes,
basically, the answer starts with the U equation.
Yes. So here G and each consumer will get utility from full G, but will pay it for private G only.
Okay, thanks.
What does it mean? G with index minus I. So I understand that it is G with index 2, but I can't understand the logic with I.
Okay, we have two consumers, and I just want to write the utility maximization problem at the one time. In general, we need to solve this problem for each consumer, but consumers have identical preferences, so we can solve the problem at one time.
Ah, okay, I see.
Okay, we can solve. Yes, G minus I is G for all other consumers, but here we have only two consumers. Okay, and now we need to solve this problem. Generally, we solve this problem by Lagrangian. Yes? Can someone solve this problem? Maybe verbally?
can we assume that they will spend equal amount on firework? So G minus I is equal to GI.
Yes, we can assume this because consumers are identical and have identical income.
Yes.
But firstly, let's solve problem generally, and we will have some kind of best response.
Well, we can see already that it's like the price of fireworks is halved, and they will spend 80% of their budget on ice cream and 20 on fireworks.
Yes, it's good that you can see it straightly, but I think that your colleague need to solve problem generally. Okay. Can someone solve this problem generally by Lagrangian? Because we need some practice of taking Lagrangian in this course. By the way, further, you are right, and GI will be 1/5 of the. Yes, thank you. Who is this?
It's me.
It's you. Is I missed who said Nikolai?
Yes.
Yes, thank you. Okay, minus lambda and budget constraint, yes.
How to I see.
Yes, it's Lagrangian, thank you. And now we need to take Fox, first order conditions here.
We are maximizing by xi and gi, right?
Yes, yes. G minus I, the consumer not decide about G minus I because this is decision of the other consumer. Okay, now we take the derivatives of the Lagrangian and minus 2 divided by xi is the derivative of 2 logarithm xi. It is not minus, it's just 2 divided by xi. Okay, and it's equal to yes, it's equal to 0. Yes. Now we took the derivative by gi, and the derivative of logarithm gi plus g minus I is 1 divided to gi plus g minus I.
Something like that.
Yes. Yes. Okay, thank you. And then we need to solve this system. We know that, okay, I will continue. We know that px is equal to 1 and pg is equal to 1. So xi plus gi is equal to 100 and xi is equal to 100 minus gi. We need to solve for gi by the task. So I will write xi by gi. Okay, and 1 divided to 100 minus gi. Oh, sorry, 2 divided is equal to lambda px, and px is equal to 1. Yes. Then 1 divided to gi plus g minus 1 is equal to lambda pg, but pg is also equal to 1. So 1 divided to gi plus, sorry, so 1 divided by gi plus g minus y is equal to lambda to 1. Okay, and let's divide this equation to the second equation. So we will have 2gi plus g minus I divided by 100 minus gi is equal to lambda divided by lambda, so it's 1. And 2gi plus 2g minus I is equal to 100 minus gi. So 3gi plus 2g minus I is equal to 100. So gi is equal to 100 minus 2gi to 3. Okay, and because of consumers are identical and the income are same, we can assume that gi is equal to g minus I. Yes.
Why is that?
So
why gi is equal to g minus y?
Because consumers are identical, they have identical preferences and identical income. So their decision for consuming GI also will be identical.
Okay.
Karen says that gi is equal to g minus y from the third equation. I don't think so. Okay, by the way, gi is equal to g minus y, so we get that 5gi is equal to 100. So gi is equal to 100 divided by 5, so it's 20.
Like from the third equation, we know that prices of x and g equal to 1. So we got xi plus gi
is equal.
Yeah, I'm not right. Okay.
Yes, is equal to 100 and yes. Gi is equal to 20. So private good is the sum of G1 plus G2. We know that G1 is equal to G2 and is equal to 20. So G is 20 plus 20, it's 40. So if public good provided by competitive equilibrium, private good will be equal to 40. Does someone has question for this problem?
How does the assumption of equilibrium help us?
Your question about how we use that public good provided in competitive equilibrium. Yes, in competitive equilibrium, each consumer will decide about consuming GI privately. So each consumer will maximize own utility.
Okay.
And then we need to determine, for example, in point B, public good. In the Pareto optimal amount, we will need to maximize the social welfare, not utility of each consumer, but the social welfare. So we use the competitive equilibrium by maximizing the own utility and saying that each consumer paid for only part of the GI, but consume G fully because this is public good anyway. Is it understandable?
So, in that case, are they working as a, I don't know, as a trust? So, as a one decision maker, if they are optimizing their sum of utilities.
Yes, if they optimize social welfare, yes, then you can say it. Yes, we can say in the way that this is some decision maker. So we will now solve for this, and you will see that the difference. Okay.
Okay.
Okay, and for the point B, we need to determine the Pareto optimal amount of public good. How we will solve this problem?
we need to maximize the sum of their utility.
Yes, it's called the sum of utilities is called
public maybe
social welfare. So now we need to maximize social welfare. Okay, who can remember what is equal social welfare from the lecture? How we can write the social welfare? Yes. Who is this? Okay,
Again.
thank you. Yes, is the sum of utilities weighted by some beta I? Yes.
Yes, and
okay, and we just need maximize this. Can you solve? Can you continue solving this?
I can try.
Yes, yes.
So I'm just following the lecture, right?
Yes, 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 yes. We solve generally, yes. Okay, and we have, yes, we have budget constraint. That's the sum of expenses to the goods.
Why is there a 0 on the right?
Is its production, yes, is production function. I think that this assumption about self about self budgeting.
What is the main idea in a few words? Because it was in a lecture, but it wasn't explained well, maybe, or I just didn't get it.
Okay, just I need to find it. In lecture, in lecture.
Can you repeat, please, why we decide that GI is equal to G minus I?
Because consumers are identical and incomes are identical.
Okay.
So their decision about consumption of GI will identical. In lecture, what is this? Function from sum of xig is equal to 0.
Yes, and on the sixth slide, it is there is a point that production possibility. So f
Yes.
from x and g is equal to 0, but what is the meaning of it?
Production possibility. So this means that we cannot make other goods by using X and G.
Okay. That
So we have,
makes sense.
yeah, we have X and G, some kind of initial welfare. Yes, okay, and this is social welfare. So, and we need write the constraint here.
It was the constraint.
Budget constraint. It is not budget constraint. It is production possibility, but we also need the budget constraint. Budget constraint is that the sum of expenses for xi of both consumers and g is equal to the sum of incomes.
What is the slide of the lecture? I don't see it. Or maybe. So now I'm looking at 10th slide.
Yes, pure public good. Yes.
So there is our function to be maximized and our constraints. So it's st, aren't they? And after they're just Lagrangian.
Yes. Yes. Yes.
I believe that production possibility assumption just replaced the budget constraint in a way. I don't know.
By the way, we need to write that the sum of expenses for xi of both consumers and g is equal to the sum of incomes. Here, we need this.
Okay. And x?
G now is pure public good.
So
we have only just G without GI. Okay, I will write
okay.
that P x to x I sum by the consumers and G plus G is equal to sum of incomes. We have consumers with income of 100, so the sum of incomes is 100 plus 100, 200. So we just have px also is equal to 1. So we have x1 plus x2 plus g is equal to 200. It is budget constraint here. And we solve
excuse me.
Yes.
So the sum of px and x I plus g is equal to sum of y's and is equal
Yes.
to 200. Okay, thank you.
Yes. Yes. Not g, but pg multiplied by g, because this expense for g. Okay.
Can you
the
please
Lagrange
write it somewhere? I don't understand that that one. So
yes, I corrected it here. I just say that not just g, but g multiplied by the price of g.
okay.
Yes, but in this problem, we know that price of g just is equal to 1. Okay, and the Lagrangian to this problem will be beta 1 multiplied by utility of first consumer, that is equal to 2 logarithm of x1 and plus logarithm of g, plus beta 2 multiplied to the utility of the second consumer, so 2 ln x2 plus ln g, and we need to write plus lambda 200 minus x1 minus x2 minus g, and we need to maximize it by x1, x2 and g. So we need to take Fox. So the derivative by x1 is equal to 2 beta 1 divided to x1 minus lambda equal to 0. Then derivative of Lagrangian by x2 is equal to also 2 beta 2 divided to x2 minus lambda is equal to 0, and derivative by g is equal to beta 1 divided to g plus beta 2 divided to g minus lambda is equal to 0. So we have beta 1 plus beta 2 divided by g is equal to lambda. And from the first and second equation, from this first and second equation, we have that beta 1 is equal to lambda x1 divided by 2, and beta 2 is equal to lambda x2 divided by 2, and we replace just beta 1 and beta 2 by these equations, and we had that lambda x1 by 2 plus lambda x2 to 2 divided by g is equal to lambda. So from here we can see that x1 plus x2 divided by 2 is equal to g. And now we remember about the budget constraint and replace in budget constraints the sum of x1 and x2 by 2g. So we will have 2g plus g is equal to 200 and g is equal to 200 divided by 3. So it is Pareto optimal allocation of public good. Does anyone have the question about this problem?
Could you please clarify how did we build Lagrangian? So we just used the formula.
Yes, we just use the social welfare. The social welfare is the sum of utilities, is the sum of weighted utilities.
Okay.
By the lecture.
I see.
And yes, and plus just budget constraint with lambda.
And if our consumers had been not similar, so we would have used another
budget constraint,
another formulas for their utilities. All right.
Yes, is the first thing, it's utility of first consumer and the utility of the second consumer. If consumer will have different preferences, we just write the utility of the first consumer and then the other utility of the second consumer. I just don't see the problem in it.
Now I got it. Thank you.
Okay, thank you. Other questions, ideas, comments? Okay, now we have only 15 students. Okay. Okay, then let's move to the second problem. And in the second problem, we asked to solve the first problem, but now consumers have different incomes. So the first consumer has the income 75 and the second consumer has the income of 125. So let's just see how we solve the first problem and where we use the incomes. We used incomes when we write budget constraint, yes? now each consumer have budget constraint that x1 plus x1 plus xi plus gi is equal to yi. And we know that y1 is equal to 75, y2 is equal to 125. Okay, and how we'll transform our Lagrangian? We need just to rewrite yi we just need to rewrite 100 by yi. Yes. So we will have the problem that minus 2 y. Okay, sorry. We can write that gi is equal to yi minus xi. So our Fox will be transformed in that way, that minus 2 divided by xi, that is replaced by yi minus xi. I replace xi by y yi minus gi.
Excuse me. Are we doing now the competitive one?
Yes, the competitive one.
Okay.
Plus 1 divided gi plus g minus I. And it's equal to 0. Yes. So we have that 2gi plus 2g minus I is equal to yi minus gi. So 3gi is equal to yi minus g minus I.
Excuse me. Could you please clarify the idea that xi is equal to yi and from
No, sorry. Xi is equal to yi minus gi by the budget constraint.
Okay, and are we using the fork from the problem 1, right?
Yes, and I decided just in the Lagrangian replace xi by yi minus gi.
Okay, in that case, could you please underline with a red line where to look to see the formula you're using right now?
Yes, of course.
Thank you.
In the first problem, we write the Lagrangian for the competitive equilibrium. Can you see?
Yes.
Yes, and I just decided replace xi by yi minus gi. why I do this? Because I need to compute only GI, and so I don't want to write the forks for XI, for GI. I don't write the one fork for GI, and that's all.
Okay, I see the Lagrangian, but you're using one of the forks formulas, right? Which one? In what condition? I just can't compare.
This one.
Ah, I see. Okay.
Sorry. I didn't use the Lagrangian. I just maximize the social welfare with constraints. So I solve this optimization problem that why social welfare utilities that UI is ln xi, that is ln yi minus gi plus ln gi plus g minus I and I maximize it by GI with the budget constraint without budget constraint, because I use budget constraint here. So I replace in the utility xi by this expression, and now I maximize it only by GI. So now I take the derivative of utility by GI, and I got this one. Do you understand?
Yes, I do. So you just have simplified the problem. So you used budget constraint and didn't use Lagrangian.
Yes, you're right. Okay, and then we see that GI is equal to YI minus G minus I is divided by 3. And we just rewrite this equation with the focus of attention that Y1 is equal to 75. So consequently, G1 is equal to 75 minus G2, yes, because G minus 1 for first consumer is G2 divided by 3. Then G2 is equal to 75 minus G1 is divided by 3. So we have the system of linear equations with G1 and G2. and we need just to solve it. If we solve it, we can get that G1 is equal to -5. That is lower than 0. But we obviously have the constraint that gi, xy, yi should be greater than 0. Do you agree?
So it's pretty difficult to consume the negative amount of something, right?
Yes. Yes. So we get the corner solution. So G1 will be equal to what if we take corner solution?
To 0.
0, yes. G1 cannot be lower than 0. So we just say that G1 is equal to 0 by the corner solution. Okay, and G2 then will be equal to what? Sorry, G1 is equal to 125 minus G1 divided by 3, yes? Because the income of the second consumer is 125. So G2 will be equal to what? Just look at this equation. We know that G1 is equal to 0. So G2 is
Equal to 125 divided by 3.
Yes, yes, thank you. So public good is the sum of G1 plus G2 and is equal just G2 and equal to 125 divided by 3. It is, if I don't mistake, it is about, yes.
It is something like 40 and 5 divided by 3.
Yes, it's 41.666 about. So it is greater than public good we got in the first problem. Yes.
Yes.
And it's much closer to the Pareto efficient allocation. Okay, does someone have question about this problem?
How can we interpret the result? So why is it closer to the Pareto efficient case?
Why it is closer to the Pareto efficient allocation? It's a good question. Okay, let's just think about it. What's the difference between first problem and the second problem? The difference in just income. Yes?
Not in just income, but in the proportion of income owned by every consumer. So the total income is the same. That's
yes. Yes, the total is the same. So maybe in the second problem we have more we have more competitive allocation. Yes.
Why is it more competitive if the second consumer have more larger budget? So maybe it is, but I don't know, frankly speaking. So
yes, I think that that when consumers are identical, if they are identical, so in the second problem they identical in preferences, but they have different incomes. They have different incomes, but they have identical preferences. So public good will provide it to the consumer that have more income, and it is more competitive situation for the market. Yes.
okay, if you say so.
So that's why this solution much closer to the Pareto efficient level. I think so.
Okay, thank you.
Okay. I think that our time out. Yes.
Yes.
Okay. We will post the full solution of the seminar, so I recommend you look at the solutions that will be posted and solve the third problem that we not covered today. I recommend you solve it firstly by yourself, and check your solution with the official solution. Okay, thank you for your participation. Thank you for those of you that participate today actively, and I hope that we will participate in the next seminar, and I hope that other students will participate too, and I hope that your colleagues will just go to the seminar next week. I hope to this.
Excuse me, and we were told that we would be given some weekly homework, so you will post it too, all right?
Yes.
And the
yes.
deadline with it, hopefully too.
Yes.
Okay.
Homework assignment, I think it was posted by Yulia Andreevna today, and the deadline will be next Friday.
Okay, and will we have seminars or lectures or so-called consultations next Friday? So we
Yeah, next Friday we don't have official lessons because of official rules of HEC for the second module and these unworking days. And maybe I will conduct some consultation for the second seminar, because we don't decided yet, but we think that with Yulia Andreevna we will get you consideration of the second seminar by yourself.
Okay. So we're waiting for your posts or letters. Okay. Thank you.
Yes. Okay, thank you. Do you have some other questions? I think that there are no questions. So thank you to everyone, and see you next seminar.
Thanks for the seminar. Goodbye.
Goodbye.